Assalamualaikum. My name is Nur Akila Shahinda binti Jamaluddin. My matrix number is B0717107080. My title project is Designing an Automatic Door for Underground Water Storage using Arduino. So today I will present to you my project presentation. So in this presentation, I will present to you the introduction, the literature review, the methodology, the result analysis, and the conclusion and recommendation. So this project idea begin with when some rural area in Malaysia do not get enough water supply at certain time. Nowadays, people make a choice to have a water storage at their own house. There are two types of water storage, which is underground water storage and groundwater storage. Between these two water storage, it have their own pros and cons. So here the objective of the project is to design an automatic door for underground water storage and to generate a circuit diagram by combining two sensors using Arduino. Others is to develop a design that have a safety feature. This is the list of job scopes in my project, which is I need to read the articles or journals that are related with water storage or rain harvesting system. And then I need to use the path table method in selecting the best design for my project. For the inlet system of the underground water storage, it is designed by combining the flood sensor and the rain sensor using Arduino software. And the estimated dimension for the inlet is 600 millimeters times 600 millimeters. So here, a few lists of some literature review for my project. Now, this is the part for the methodology project. This is how the methodology running. So, at first, I need to do study on research about climate and design. Okay, and then I need to select the sensor, which is I select flood sensor and the rain sensor. For the door concept, I need to finalize the concept for the automatic door, including the measurement. For the selection material, I need to select the material specification that's suitable for this project and the final material. So here is the hardware and software for this project. I use rain sensor, flood sensor, and I use software Arduino. That is the open source Arduino software to write coding and upload it to the board. Then I'm using connecting wire in type male to male for 16 units. For the connecting wire female to male, I'm using only 8 units. In the designing of the door, I'm using Katia V5. That is the multi-platform software for computer-aided design. Next is the breadboard and the micro servo tower Pro ST90. For the micro servo, I'm using 4 units. In designing the circuit, I'm using FreeZing software, that is the open source for the electronic project. Next, I need to use battery 9V to support the power supply because I'm using 4 servo. And then I need to have wire tip. For the software in analysis, I'm using NZIS software, which is the engineering simulation and 3D design software. The last is the Arduino Uno. I need to use this because this Arduino Uno will connect directly to the software Arduino. This is the step-by-step diagram for this project. It will start from define problem statement and decide the project title. After finding the objective and the solution to solve the problem, I will do the research about sensor and find the design for inlet water storage. And then, I will decide either design and the sensor is accepted or not. If yes, I will insert the design and do analysis using Arduino. If not, I need to find the objective and the solution again. After insert the design and do analysis in Arduino, I will record the result and include in the report. The main objective for this research design is to make underground water storage more easy to use. The characteristic for the door design is flexibility and have a safety feature since this automatic door will put at the house area and it needs to suitable for outdoor usage. And then the other is weatherproof. This is the proposed design. First one is the automatic door with two sliding. The second one is the automatic door with circular lid. And the third one is automatic door in single slide with side glass. On this part, I will show you how the sensor flow. At first, the rain sensor will sense the rain. If there is raining outside, the automatic door will open. And then, the process of collecting water is running. And then, the flood sensor will sense the water level inside. If the water level is exceed, so the door will close even though it is raining outside. But if the sensed water level is not exceed, it will still remain open the door. So basically, the rain sensor function is to use to control the movement of the door. The door will open automatically when the sensor detects rainfall or water drop and allow the water to get into the underground water storage. For the flood sensor, the main function for this sensor is to control the amount of water inside the underground water storage tank. This is to ensure that there is no overflow water in the water storage to protect the moisture of the soil. This is important to control or protect the moisture of the soil because the moisture of the soil will affect the house structure day by day. So for the door opening, the automatic door have the 4 simultaneous opening where the door will stand around the water storage to allow the process of collecting water. For the sensor location, the flood sensor will be at the underground water storage tank, while for the rain sensor, it will be at the top of the door platform. And how it works, when the door works, it will open all door openings simultaneous that will stand around the opening of the underground water storage about 90 degrees. It is to avoid possibility of person can fall down onto the water storage if they do not detect the existence of the underground water storage. This is the final design for my project. This design has safety feature that will work when the system is jammed. The 4 door opening will remain stands around the door to prevent people from fall in the water storage due to the carelessness. The material for the door is stainless steel 304. That is, the stainless steel 304 have durability that make it easy to sanitize. And it also can withstand the long-term exposure and excellent in corrosion resistant. Now we go to the result and analysis. So I'm using static analysis using NZIS software. So the material is stainless steel 304. The weight that I get from this analysis is 42.363 kg and the von Mises stress is 108.41 MPa. And the maximum shear stress is 55.67 MPa. For the type of connection, I am choosing hinge in type of damper hinge. This is the example of damper hinge. So, this is the operation time. Time for the door open, it will take time 9.39 seconds and for the door close is 15.59 seconds. For the speed of the door motion, I assuming the force applied to the design is 100 Newton and then I'm using the equation F equals to ma, which is A is the acceleration. So in this equation, I need to find the acceleration. Mass I already get in the analysis, which is 42.363 kg. So the analysis calculated is 2.3606 m per s square. From the acceleration, I need to find the velocity. The velocity is acceleration times with the difference time between door open and close. So, 2.3606 times 6.2 seconds and I will get the velocity is 14.64 meter per second. During analysis, the mechanism was added into the design. It is because to make sure the analysis is running smoothly. However, this mechanism is added just for the analysis in ANSYS software. The Arduino coding that I use in this project is declaration method, loop method, and if-else statement method. The declaration method is a basic and it is a need for coding in Arduino. It is need to declare the force servo and the rain sensor and flood sensor. For the loop method, it is need due to the repetition on the project system. It started from the rain sensor detect rain until the flood sensor detect the tank is fully filled. The if-else statement method is used in this project because the condition in the project system. This is the final circuit design in Arduino. This circuit is changed due to the added of force servo mechanism and the circuit design become complex than before. Next, the sensitivity of sensor is testing. It is important to know the susceptibility of the sensor because this will affect the project system. The flowchart testing is start from to prepare all the tools needed and set up the installation of the sensor, and then fill in the water as prescribed and set up the basic Arduino coding. And the output result is recorded. So the flood sensor testing. So you can see the installation of flood sensor. That is how the circuit testing for the flood sensor. And then the testing setup is the level of water will change to get the difference output. It's because the more the water, the higher the output of the testing. Okay, so that is the example output testing for the lowest level water. So as you can see, the different water level will produce the different output result. The higher the water level will produce the higher the output result. This is how the rain sensor testing installation. And the testing setup is the water need to flow directly onto the sensor to get the rain warning output. If the water is not flowing directly into the sensor, the output will produce not raining. So this is the rain sensor result testing. So you can see the water level, different water level, and the condition, either it directly flow or not directly flow, and you can see the output. So as you can see, at water level 0.025 liter, I do not flow the water directly onto the sensor, so the output is not raining. While for water level 0.075, I'll directly flow the water onto the sensor and the output is 1 raining. So for the discussion, the circle need to rebuild because of the addition of the force servo. The force servo is added due to the motion of each of the opening door. The servo need to attach at the edge of the opening door. The final coding was changed because the combination of the two sensors. For the sensitivity of sensor testing, it is important to know that either the sensor is function or not. Now, it's your time to watch my prototype project. Okay, let's go. Before that, I would like to show you my simulation video for my project. Now, it's time to enjoy my prototype video. So now I will show you the illustration of underground water storage. So I attach the water level sensor into the underground water storage. Okay, so the orange manila card is the illustration of 4 opening door. So as you can see, I flow directly the water to the rain sensor, which is the water is the imagination of the rain, so the door will open. Okay, now I fulfill the tank. Okay, I fully filled the tank with the water, and then I tried to flow the water directly onto the sensor, and you can see the door will not open. So here I remake the video to show you when I do the illustration of the rain. So as you can see, when it is raining, the door will open. Okay, when the rain stop, okay, the door will close. So for this part, this is the real situation when the rain do not stop. Okay, so you can see the door will remain open until the underground water storage is fully filled. Okay, when the underground water storage is fully filled, the door will close automatically and it will do not open even though it is raining. So basically, this system will use the consumer to use the underground water storage. This door system also provides a standard timing for automatic door, which is 6.2 seconds, and it is the safest design compared to the other proposed design. This is the future work for the project. Thank you, sir, for your time to watch my presentation. Assalamualaikum. This is the future work for this project.